Picture this. A massive steel ship, longer than a football field, weighing over 14,000 tons, sliding into the water. Nothing unusual about that, right? Ships get launched all the time. But here is what made this moment absolutely insane. This ship had been assembled, yes assembled, in just 4 days. Not 4 months. Not 4 weeks. 4 days. And the people who built it, they were not shipbuilders. Most of them had never even seen a ship being made before a few weeks earlier. They were farmers, teachers, housewives, people who had been doing completely different jobs just months before. And they had just done something that every expert in the world said was totally impossible. Now, I know what you are thinking. How is that even possible? Ships are massive, complicated machines. They have to float, carry tons of cargo, survive storms at sea. Building one takes skill, experience, years of training. At least, that is what everyone believed. For hundreds of years, building a cargo ship took anywhere from 6 to 8 months. The best shipyards in America, the ones with the most experienced workers, the finest equipment, the longest traditions, they needed half a year minimum to build a single vessel. And suddenly, here comes this guy who has never built a ship in his entire life, and his workers are cranking them out in days. Not just one ship as a crazy stunt, but thousands of them. Ships that actually worked. Ships that won a war. This is the story of how one man walked into an industry that had been doing things the same way for centuries and completely turned it upside down. And he did it by breaking every single rule the experts swore you had to follow. This is about the Liberty ships, and the man who proved that impossible is just another word for nobody has figured it out yet. Let me take you back to late 1940. Europe is burning. World War II is raging across the Atlantic. Britain is fighting for its life against Nazi Germany, and here is the problem. German submarines, called U-boats, are sinking British supply ships faster than Britain can replace them. Every week, more ships go to the bottom of the ocean. Food, fuel, weapons, everything Britain needs to survive and fight, it all has to come across the Atlantic Ocean on cargo ships. And those ships are being destroyed. Britain is literally starving. Their shipyards are working as fast as they can, but it is not nearly fast enough. They turn to America for help. Can American shipyards build cargo ships to replace what is being lost? The answer is complicated. American shipyards can build ships, sure. But they are slow. Really slow. Using traditional methods, American yards needed about 230 days to build a single cargo vessel. That is almost 8 months. Do the math. If German subs are sinking ships every single day, and it takes you 8 months to build a replacement, you are going to lose. Simple as that. The US government knows they have a massive problem. They need ships, lots of them, and they need them fast. So they start looking for shipyards that can take on huge contracts. And this is where our main character enters the story. His name is Henry Kaiser. And here is the thing about Henry Kaiser. He has never built a ship. Not one. He has never managed a shipyard. He has never worked in the maritime industry. He is a construction guy. He builds dams. He pours concrete. He moves dirt. That is what he does. So when Kaiser walks into the U.S. Maritime Commission in December 1940 and says, "Hey, I will build you 30 cargo ships in 2 years, the reaction is pretty much what you would expect. The actual shipbuilders, the people who have been doing this their whole lives, whose fathers and grandfathers built ships, they laugh at him. They think he is either crazy or a con artist trying to make a quick buck off the war. One of the oldest, most respected shipyards in America, Todd Bath Iron Works, agrees to partner with Kaiser on the deal, but only because they assume they will be doing all the real work while Kaiser just provides money and workers. They figure his ignorance will not matter because they will be there to fix his mistakes. Nobody, and I mean nobody, understands that Kaiser's complete lack of experience is about to become his biggest advantage. See, when you have been doing something the same way your whole life, when you learned it from people who learned it from their parents, when you have all these rules about the right way and the wrong way, it becomes really hard to imagine doing it differently. you get stuck in tradition. But Kaiser, he has no tradition. He does not know the rules. And that means he is free to ask a very dangerous question. Why? Kaiser and his engineers start looking at how ships are built. They visit traditional shipyards and watch the process. And what they see seems incredibly inefficient to them. In a traditional shipyard, you build a ship in sequence. First, you lay the keel, the bottom spine of the ship. Then you build up the frame, piece by piece. Then you add the outer hull, plate by plate. Then you build the internal structures, the decks, the bulkheads, the compartments. Everything happens one step after another, in order, from bottom to top. And here is the really slow part. You cannot install the engine until you have built the engine room. You cannot build the engine room until you have built the hull around where the engine room will go. Everything depends on everything else being finished first. It is like building a house where you are not allowed to work on the roof until the entire first floor is completely done, and you are not allowed to work on the plumbing until all the walls are up. One thing at a time, in order, step by step. Kaiser looks at this and thinks, this is insane. Why are we doing it this way? And one of his top engineers, a guy named Clay Bedford, has just visited a Ford automobile factory in Detroit. Bedford watches cars being assembled on a production line. Different workers at different stations, each doing one specific job, with parts being made in advance and then brought to the assembly line when needed. The car moves down the line, and at each stop, workers add pre-built components. Engine goes in here, wheels go on there, doors get attached at this station. Everything happens in parallel. While one car is getting its engine, another car 20 feet away is getting its wheels, and another car is getting its seats. Multiple things happening at the same time, all moving forward together. Bedford comes back to California and tells Kaiser, we should build ships like Ford builds cars. The traditional shipbuilders hear this idea and they think it is the dumbest thing they have ever heard. Ships are not cars. Ships are massive, complex, floating structures. You cannot just slap them together on an assembly line. It is absurd. Ridiculous. It will never work. Kaiser decides to try it anyway. But before he can even think about assembly line production, he has to deal with an even bigger problem. Rivets. Traditional ships are held together with rivets. A rivet is basically a metal pin. You heat it up until it is red hot, stick it through holes in two pieces of steel plate that are overlapping, and then hammer both ends flat so it locks the plates together. It works. Ships have been built this way for decades. But it is slow. Incredibly slow. A really good riveting crew, working perfectly together, could install maybe 100 rivets in a day. And a Liberty ship, built the traditional way, would need about 1 million rivets. Let that sink in for a second. 1 million rivets. Even if you had 10 crews working simultaneously, that is still thousands and thousands of hours just for riveting. Kaiser says forget rivets. We are going to weld everything instead. Welding uses electricity to melt steel at the edges and fuse two pieces together. It is faster, it uses less metal, and you need fewer workers to do it. Kaiser has used welding for years building pipelines out west. He knows it works for large steel structures. But the maritime industry does not trust it. The British Navy actually forbids welding on warship hulls because they are worried about the strength. Rivets have worked for a century, why change? The head of the U.S. Maritime Commission, a Navy admiral named Emory Land, reads Kaiser's proposal and he is deeply skeptical. He basically says, you want us to bet America's entire supply line on an unproven technology? Are you serious? But here is the thing. Admiral Land is also desperate. In 1941 alone, Allied shipping is being sunk faster than anyone can build replacements. Millions of tons of ships are going to the ocean floor. Britain is running out of food. At the rate traditional shipyards work, the Allies are going to lose the war before American industry can even ramp up production. So Land makes a decision. He does not approve Kaiser's plan because he thinks it is good. He approves it because he is out of options. It is a desperation move. Build ships your crazy way, Kaiser. If it works, great. If it fails, we are not any worse off than we already are. Kaiser gets his contract. Now he has to actually build a shipyard. Between January and December 1941, his construction crews build a facility in Richmond, California. And when traditional shipbuilders come to look at it, they are horrified. It does not look like a shipyard. It looks like a factory. There are huge open areas for building ship sections away from the water. There are railroad tracks everywhere, designed to move giant pieces of steel around. There are massive cranes, way more crane capacity than any normal shipyard would ever need. The building ways, the ramps where ships actually get assembled, are shorter than usual. Everything about the design violates traditional shipyard principles. One veteran shipbuilder, a guy with 30 years of experience, writes a report after visiting Richmond. He says Kaiser has broken every rule of efficient shipyard layout. The prefabrication areas are too big. The cranes are absurdly oversized. The building ways are wrong. But then he adds something interesting. He says, I have to admit, the facility is designed for exactly what Kaiser claims he wants to do, rapid assembly of pre-made sections. The shipbuilder does not think it will work. But he can see that Kaiser has a plan, even if it seems crazy. Now Kaiser needs workers. Traditional shipyards recruit from families that have been building ships for generations. Skills get passed down from father to son, mother to daughter. You grow up around ships, you learn the trade over years, you become part of a maritime community. Kaiser does not have time for any of that. He puts ads in newspapers all across America. The ads say, we will pay you 20% more than normal factory wages, and we will train you to do the job. No experience necessary. Come to California, we will teach you to build ships. And people come. Thousands of them. They come from farms in Oklahoma. They come from offices in Chicago. They come from small towns all over the country. They show up in Richmond, and most of them have never even seen the ocean before, let alone built a ship. The first groups arrive in August 1941. Traditional welders spend 4 years as apprentices learning how to weld properly. Kaiser's training program lasts 2 weeks. 2 weeks. The instructors teach workers one specific task. Not how to weld everything. Just how to weld this one type of joint. Vertical seams on bulkheads. Or horizontal plates on decks. Or curved sections on the hull. Whatever that worker is going to be doing over and over again, that is what they learn. Nothing more, nothing less. And here is where Kaiser's factory thinking really pays off. In traditional craftsmanship, you learn everything so you can adapt to any situation. You become a master of the whole process. That takes years. But if you break the process down into small, repeatable tasks, and you teach people just those specific tasks, they can become really good at that one thing very quickly. It is the same principle as the assembly line. You do not need every worker to know how to build a whole car. You just need each worker to be excellent at installing wheels, or connecting wiring, or whatever their station requires. Kaiser applies this to shipbuilding. By October 1941, Kaiser has over 10,000 workers in Richmond. Fewer than 200 of them have any previous maritime experience. And they start building ships. The first Liberty ship takes 197 days. Not great, but not terrible for a first attempt with untrained workers. But then something interesting happens. The second ship takes 169 days. Ship number 5 takes 128 days. Ship number 10 takes 97 days. The time keeps dropping. By spring 1942, Richmond is completing Liberty ships in an average of 70 days. Traditional shipyards are watching this and freaking out. These untrained farmers and housewives are now building ships as fast as professional shipbuilders with decades of experience. How is that possible? The answer is the prefabrication system. Instead of building a ship from bottom to top in sequence, Kaiser's yards build entire sections of the ship simultaneously in different parts of the facility. Think about it like this. In one area, a crew is assembling the bow, the front of the ship. In another area, a different crew is building the stern, the back of the ship. In another area, workers are constructing the deckhouse, the structure on top. In another area, the engine room is being assembled. In another area, the cargo holds are being built. All of this is happening at the same time. Different teams, different locations, all working in parallel. And here is the brilliant part. When all these sections are complete, giant cranes pick them up and move them to the building way, the ramp where the ship gets put together. The workers there weld the sections together. Bow to middle, middle to stern, deckhouse on top, engine room drops in from above. What used to take weeks or months of sequential construction now takes hours of assembly. It is like building with enormous Lego blocks. The blocks are pre-made. You just snap them together. Let me give you a specific example that shows how radical this is. In a traditional shipyard, installing the engine takes about 3 weeks. You have maybe 50 workers trying to fit this massive, heavy engine into a cramped, partially built engine room. They have to maneuver it carefully, bolt it down, connect all the pipes and shafts, and they are working in a tight space the whole time. It is slow, difficult work. Kaiser's approach is completely different. 200 workers assemble the engine and its entire mounting structure in an open workshop over 5 days. They have room to work. They have good lighting. They can access every side of the engine easily. When the engine assembly is completely finished and tested, a crane lifts the whole thing, all 140 tons of it, and drops it into the engine room opening in a single 8-hour shift. Then the workers just weld it in place. Task that took 3 weeks now takes 1 day. That is not a small improvement. That is a revolution. Traditional shipbuilders are not just surprised by this. They are offended. Kaiser is violating sacred principles of their craft. Ships have always been built from detailed plans that specify every tiny detail. Kaiser uses simplified drawings that give basic dimensions and then lets workers figure out the details on the spot. Traditional builders think this is reckless. Kaiser calls it flexible. If a worker sees a better way to connect 2 pieces, they do it. They do not have to wait for an engineer to approve a modification to the plans. They just solve the problem and move on. A Navy admiral named Howard Vickery is in charge of overseeing ship production for the government. At first, he fights against Kaiser's simplified specifications. He says ships are not automobiles. You need precision. But by March 1942, Kaiser's yards are outproducing traditional contractors by 40%. By June, the gap is 70%. And Admiral Vickery has a realization. He later says, "I learned that perfection is the enemy of sufficient." Kaiser's ships are not beautiful. They are not elegant. But they are adequate. And adequate ships delivered now are more useful than perfect ships still under construction 6 months from now. As construction speeds keep increasing through 1942, competition develops between Kaiser's different shipyards. He has 7 yards total, spread across California, Oregon, and Washington. His son Edgar runs the yards in Oregon. Clay Bedford oversees the Richmond yards in California. And these 2 guys start an informal race to see whose facility can build ships faster. They are both ambitious, both driven, and they start pushing their workers to break records. The competition becomes public. Newspapers start printing updates like sports scores. Portland builds a ship in 10 days. Richmond tries to beat that. The records keep falling. Eventually, the Navy orders them to stop because the speed competitions are becoming stunts that distract from actual production goals. But the competitions served their purpose. Workers across all 7 Kaiser yards now believe that extraordinary speed is not just possible, it is expected. If Portland can do it in 10 days, we can do it in 9. If Richmond can do it in 9, we can do it in 8. The culture shifts from, "we are doing pretty well," to, "what is the absolute limit of what is possible?" November 1942. Admiral Land visits the Richmond Shipyard to inspect production. He is talking to reporters, and he makes an offhand comment. He says something like, "Liberty ship construction has improved remarkably, but even the recent speed records are nothing compared to what true mass production has achieved in other industries. Clay Bedford, who runs the Richmond yards, overhears this comment, and he takes it as a personal challenge. He goes to Admiral Land and makes a proposal. Richmond Yard No. 2 will build a complete Liberty ship, from laying the keel to launching it into the water, in under 10 days. That would cut the current record in half. Admiral Land is skeptical but intrigued. He says fine, try it, but do not disrupt regular production schedules at the other yards. Bedford picks hull number 47 for the record attempt. The ship will be named the SS Robert E. Peary, after the famous Arctic explorer. Starting at 1 minute past midnight on Sunday, November 8th, over 1,000 workers in carefully coordinated shifts will attempt something that has never been done in the entire history of shipbuilding. And this is where all the prefabrication strategy reaches its ultimate expression. Before the keel even touches the building way, every major component of the ship has already been built and is sitting ready to go. The bow section, fully welded and equipped with anchor hardware and crew quarters. The stern section, complete with steering gear and propeller shaft. 4 massive cargo holds, each one a giant rectangular steel box. The engine, 140 tons, already mounted on its foundation and tested at the factory where it was made. Everything is ready. They just have to put it together. The keel goes down. The clock starts. Teams of workers move like a choreographed dance. Sections get lifted by cranes and positioned. Welders swarm over every joint, fusing steel together. Sparks fly 24 hours a day. One shift ends, another begins, no breaks, no slowdowns. 4 days into construction, the hull is complete. The engine is installed. The deckhouse is positioned. The cargo holds are secured. The steering gear is mounted. On Thursday, November 12th, at 3:30 in the afternoon, just 4 days, 15 hours, and 29 minutes after the keel was laid, the SS Robert E. Peary slides down the launching rails into San Francisco Bay. The crowd watching includes military officers, government officials, competing shipyard owners, and journalists from all over America. Many of them came expecting to witness either a complete failure or a ship that looks done but is actually a non-functional mess. What they see instead is a fully operational vessel that only needs minor finishing touches before entering service. The ship is delivered for active duty on November 15th. From keel laying to full delivery, 7 days and 14 hours. A complete, working cargo ship in a week. Admiral Land, who is there for the launch, makes a short speech that gets recorded by newsreel cameras. He says, 6 months ago, I would have called this impossible. Traditional shipbuilding wisdom accumulated over 3,000 years said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The United States Maritime Commission will now require all contracted shipyards to adopt these methods. Think about what that means. The government is now forcing all the traditional shipyards, the ones that laughed at Kaiser 2 years earlier, to copy his techniques. The old guard has lost. The revolution is complete. The president of New York Shipbuilding Corporation, one of the oldest and most prestigious yards in America, visits Richmond in December 1942. He writes a confidential report to his board of directors. And in this report, you can see the complete collapse of traditional thinking. He says, Kaiser has achieved what our industry considered impossible by refusing to accept our limitations. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise. The result is ships built in 1/10 the time at 2/3 the cost. We must either adopt his approaches or accept irrelevance. By early 1943, 18 shipyards across America are building Liberty ships using Kaiser's prefabrication and welding methods. Average construction time has fallen from 230 days to 42 days. The United States is now launching 3 Liberty ships every single day. More tonnage than German submarines can sink. The math of the war has shifted. Germany cannot win a war of attrition against this level of production. It is impossible. You cannot sink ships faster than your enemy can build them when your enemy is building 3 per day. But maybe the most revolutionary aspect of Kaiser's achievement is who is building these ships. At peak production in 1944, Kaiser's 7 yards employ about 196,000 workers. Over 40,000 of them are women. Women comprise 27% of the workforce at Richmond. African American workers number in the tens of thousands, employed in skilled positions including welding, crane operation, and even supervisory roles. This level of workplace integration is extremely unusual for 1940s America. Remember, this is still a segregated country in many places. But Kaiser's yards are proving that women and minorities can do complex industrial work just as well as anyone else, given training and opportunity. This matters for reasons beyond just the war effort. Kaiser is demonstrating that the old guild system, where skills are passed down through families and certain people are excluded based on gender or race, is not necessary. Complex manufacturing can be done by anyone who is properly trained and motivated. This is a direct challenge to the social hierarchy that has existed for centuries. And it is being proven not through arguments or protests, but through production statistics that nobody can deny. The ships get built. They work. End of discussion. Christmas 1943 provides another glimpse into Kaiser's transformed industrial culture. Traditional shipyards observe the holiday with a day or 2 off. Kaiser's facilities keep running. But instead of just demanding that people work through Christmas, Kaiser's organization throws celebrations right there at the shipyards. Christmas dinner is served in the facility cafeterias. Turkey, ham, all the traditional food, provided free to everyone on shift. Local churches send carolers. The Richmond Municipal Band performs. Kaiser himself visits the yards, walking around, shaking hands with workers, personally thanking them for their service. He understands that you cannot just demand extraordinary effort from people. You have to show them they are valued and appreciated. By mid-1944, Kaiser's 7 shipyards have produced over 800 Liberty ships. But his influence extends far beyond his own facilities. The 18 American shipyards building Liberty ships have collectively produced 2,400 vessels. A larger, faster design called the Victory ship is now being built using the same prefabrication and welding techniques. Total American maritime production between 1941 and 1945 exceeds 5,500 vessels. That is about 53 million tons of shipping. To put that in perspective, that is more tonnage than the rest of the world combined. A British Royal Navy commander assigned to watch American production sends reports back to London. His reports, which were declassified decades later, show how the British viewed what was happening. He writes, "The United States is building merchant shipping at a rate that exceeds the combined capacity of the rest of the world. Kaiser alone produces more tonnage monthly than the entire British shipbuilding industry. The approaches are crude by our standards. The ships are not elegant, but they float. They carry cargo, and there are thousands of them." The Royal Navy builds the finest warships in the world using traditional craftsmanship. The Americans build adequate ships in weeks. Adequate multiplied by thousands defeats perfection multiplied by dozens. That is the lesson right there. Perfection multiplied by dozens loses to adequate multiplied by thousands. It does not matter how good your craftsmanship is if you can only build a few ships. Volume matters. Speed matters. Adequate ships delivered today beat perfect ships delivered next year. This is a hard lesson for traditional craftsmen to accept. But the war does not care about tradition. The war cares about results. When the war ends in September 1945, Liberty ship production stops immediately. By December, Kaiser's workforce has dropped from 200,000 to fewer than 20,000. The Richmond shipyards that employed 100,000 workers at their peak are mostly empty by spring 1946. Many people expected the whole program to just disappear, a temporary wartime emergency response with no lasting impact. They were wrong. The knowledge developed during the emergency did not vanish. The prefabrication techniques, the welding procedures, the parallel assembly approaches that Kaiser pioneered became standard practice worldwide. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they studied Kaiser's Liberty ship program. They adopted his methods as the foundation for their new yards. The massive shipbuilding facilities in Ulsan, South Korea, and Nagasaki, Japan, that dominated world shipping construction for decades, are direct descendants of Kaiser's revolutionary practices from Richmond, California. A professor of maritime history named John Bunker wrote a comprehensive study of Kaiser's influence in 1972. He said, "Kaiser entered shipbuilding as an outsider, ignorant of maritime tradition, unconstrained by conventional wisdom, and willing to apply manufacturing principles that the established industry considered inappropriate. In 36 months, he built more ships than had been constructed in America during the entire previous century. More importantly, he fundamentally altered how ships would be built worldwide for the rest of the 20th century. The modular construction, prefabrication, and welded assembly that Kaiser pioneered are now universal standards. Every modern shipyard, whether building container vessels in Korea, oil tankers in Japan, or cruise ships in Europe, uses approaches derived from Kaiser's Liberty ship program. Let me give you some statistics that show just how incredible this achievement was. Total production: 2,710 Liberty ships built across 18 American yards between 1941 and 1945. At peak production, that is an average of 1.8 ships per day. Kaiser's 7 yards alone produced 1,490 ships, representing 27% of all American wartime merchant shipping. Construction time fell from 230 days average in 1941 to 42 days by 1943. The record holder, the Robert E. Peary, took just 4 days and 15 hours from keel laying to launch. Labor efficiency improved dramatically as workers gained experience. The first Liberty ships required about 1.1 million worker hours to complete. By 1943, that had fallen to about 486,000 worker hours per ship. Kaiser's most efficient yards achieved construction in as few as 350,000 worker hours by running 3 shifts, 24 hours a day, and maximizing prefabrication. Cost efficiency matched the schedule improvements. The first Liberty ships cost about $1.75 to $2 million each. By 1943, costs had fallen to around $1.3 million despite rising wages and material prices. That is pure efficiency gain from the learning curve. Each Liberty ship displaced 14,245 tons when fully loaded and could carry 10,800 tons of cargo. That is 2,840 jeeps, or 440 tanks, or 230 million rounds of ammunition in a single voyage. The ships were powered by old-fashioned triple expansion steam engines. Kaiser deliberately chose outdated engine technology because it was reliable and easy to manufacture. The ships achieved speeds of 11 knots, which is about 12.5 miles per hour. Not fast, but adequate for convoy operations where ships traveled together for protection. Training efficiency was equally remarkable. Kaiser's training schools taught workers specific tasks in an average of 2 weeks. The fastest training produced productive spot welders in just 10 days. More complex positions like crane operators or ship fitters required 4 to 6 weeks of training. Compare that to traditional maritime apprenticeships that lasted 4 years for basic competency and 10 years for master craftsman status. The key difference was specialization versus comprehensive training. Traditional apprentices learned everything about shipbuilding. Kaiser's workers mastered specific, repeatable tasks. What about the quality of these rapidly built ships? Were they any good? The battle casualty rates tell the story. Of 2,710 Liberty ships built, approximately 200 were lost to enemy action. That is a loss rate of 7.4%. This compared favorably with pre-war merchant shipping loss rates and proved that welded construction produced seaworthy vessels. Some ships did experience structural failures due to welding defects. 3 Liberty ships broke completely in half due to brittle fracture problems. That represents 0.11% of total production. About 1,500 instances of significant cracks occurred across the Liberty fleet, but catastrophic complete breaks were extremely rare. These failures led to improved welding procedures and better steel specifications that eliminated the problem by 1944. The longevity statistics provide the ultimate proof that Kaiser's construction methods worked. Liberty ships were designed as emergency vessels with expected service lives of 5 years. They were supposed to be temporary. Use them during the war, then scrap them. But they proved remarkably durable. Many remained in service for decades after the war. The SS John W. Brown, built in 1942, is still operational as a museum ship in Baltimore as of 2024. That is 82 years after construction. The SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and actually sailed to Normandy under its own power in 1994 for the 50th anniversary of D-Day. A 52-year-old ship making an ocean voyage. A third Liberty ship, the Hellas Liberty, serves as a museum ship in Greece. Of the approximately 2,510 Liberty ships that survived the war, about 835 remained in commercial service through the 1960s. Many were sold to foreign shipping companies and operated into the 1970s. The SS Albert M. Bow, the very last Liberty ship built and delivered on October 30, 1945, still exists today. It was sold in 1964, converted to a fish cannery ship called Star of Kodiak in 1965, and today sits on land as the headquarters of Trident Seafoods in Kodiak, Alaska. Still in existence 8 decades after construction. The economic impact of the Liberty ship program rippled through American industry. The massive steel requirements drove expansion of steel production capacity. Kaiser built the Fontana Steel Mill in California specifically to supply his shipyards. This mill, completed in 1942, produced about 700,000 tons of steel annually and established California as a major steel-producing region for the first time. Employment effects transformed entire communities. The city of Richmond, California, grew from a population of 23,000 in 1940 to over 100,000 by 1943, driven entirely by shipyard employment. Kaiser built Vanport City in Oregon, which briefly became the state's second-largest city with a population exceeding 40,000, all of whom worked in shipyards or supporting industries. These boomtowns were temporary, but they demonstrated the transformative power of concentrated industrial investment. An unexpected legacy emerged from Kaiser's shipbuilding program: healthcare innovation. To provide medical care for his massive workforce, Kaiser partnered with a physician named Sidney Garfield to establish prepaid healthcare programs. Workers paid a small amount from each paycheck and received medical care when needed. This model eventually evolved into Kaiser Permanente, one of America's largest health maintenance organizations. The prepaid preventive healthcare pioneered in the shipyards influenced American medical practice for decades and served over 12 million members by the early 21st century. The workers themselves carried forward the lessons of their wartime experience. The shipyards gave thousands of young people, especially women and minorities, opportunities they never would have accessed through conventional career paths. A young woman who learned to weld in 1942 might have spent the rest of her life as a secretary or housewife in the old system. Instead, she spent decades in skilled industrial work, earning good wages, supporting her family, proving that women could do anything men could do given the chance. An African-American man who learned crane operation at Richmond might have been limited to menial labor in the old system. Instead, he spent his career as a skilled equipment operator, bought a house, sent his kids to college, built a middle-class life that would have been impossible before. The technological innovations developed during the Liberty ship program influenced industries far beyond maritime construction. The welding techniques refined under wartime pressure became standard in structural steel construction, petroleum refining equipment, and pressure vessel manufacturing. The prefabrication approaches pioneered at Richmond influenced construction practices in housing, bridge building, and industrial facilities. The organizational principles of parallel production, simplified specifications, and rapid worker training became foundational concepts in business schools. Professor Michael Porter at Harvard Business School, analyzing American industrial competitiveness in a 1985 study, identified the Liberty ship program as a crucial case in rapid capability development. He wrote, "Kaiser demonstrated that industrial capacity is not fixed but can be created quickly when necessity demands. The United States entered World War II with minimal merchant shipbuilding capability. Within 24 months, American yards were producing more tonnage than the rest of the world combined. This proved that industrial infrastructure, workforce skills, and production systems could all be developed at unprecedented speed when properly organized. That lesson has relevance beyond wartime emergency. It suggests that perceived limitations on industrial capacity often reflect organizational and conceptual constraints rather than physical impossibilities. The psychological transformation that the Liberty Ship program created among industrial managers and engineers proved as significant as the physical ships produced. Before Kaiser, manufacturing executives accepted conventional wisdom about production limits, skill requirements, organizational structures. Kaiser demonstrated that conventional wisdom could be wrong. That breakthrough performance required questioning fundamental assumptions. The Liberty Ship story ultimately stands as proof of a profound truth about human capability and industrial possibility. The ships themselves, while crucial to Allied victory, mattered less than what their construction proved. Ordinary people, given training and opportunity, could achieve extraordinary results. Complex products previously requiring years of craft tradition could be manufactured in weeks using systematic processes. Industries resistant to change for centuries could be revolutionized in months when necessity and innovation combined. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic impact of American maritime production in his memoir published in 1960. He wrote, "We fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them." Japan's military planners assumed American industrial capacity was impressive but finite. They believed that if they sank enough ships, eventually American logistics would collapse and we would be forced to negotiate. They failed to account for Henry Kaiser. By 1944, we were replacing shipping losses faster than they could inflict them. The mathematics of attrition favored the side that could build 3 ships daily over the side that could sink 2 ships daily. Industrial capacity, not martial valor, determined the outcome. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore as much as on the beaches of Iwo Jima and Okinawa. In the end, Kaiser's greatest achievement was not the 1,490 ships his yards produced. It was the transformation of what industries believed possible. The Robert E. Peary, built in less than 5 days, stood as tangible proof that tradition does not equal truth. That conventional wisdom can be questioned. That revolutionary improvement requires revolutionary approaches. The maritime establishment that dismissed Kaiser as an ignorant outsider in 1940 spent decades after 1945 studying and implementing his techniques. The young workers who learned to weld and fit and fabricate carried those skills and that confidence into peacetime careers that rebuilt America's post-war economy. The approaches pioneered under wartime emergency became peacetime standards that influenced manufacturing across industries and around the world. The story of how one man's approach made Liberty ships appear in days instead of months is ultimately a story about the power of questioning assumptions. It proves that the greatest breakthroughs often come from people who are not trapped by tradition. That progress requires challenging accepted limits. That human potential exceeds conventional expectations when systems are properly organized and people are given real challenges to meet. Kaiser's workers were not superior humans. They were not specially gifted. They were ordinary people achieving extraordinary results because someone believed they could and created systems that allowed them to prove it. A farmer from Kansas became a skilled welder. A housewife from Ohio became a crane operator. A secretary from Illinois became a ship fitter. These were normal people doing things that experts said required decades of training. And they did it because nobody told them it was impossible until after they had already done it. Think about what that means for a second. How many other impossible things are only impossible because we accept that they are? How many industries are stuck doing things the old way simply because that is how they have always been done? How many breakthroughs are waiting for someone who does not know enough to realize they should not try? Kaiser did not know you could not build a ship in days. So he tried. And it worked. That is a powerful lesson. The Liberty ships themselves are mostly gone now. Most were scrapped decades ago. Some rest on ocean floors. A few survive as museum ships, silent testaments to an incredible moment in industrial history. But the revolution they represented endures. It lives in every modern shipyard that uses prefabrication. In every manufacturing facility that breaks complex processes into simple, repeatable tasks. In every training program that teaches specific skills quickly rather than broad expertise slowly. In every manager who looks at an impossible problem and asks, is it really impossible, or has nobody figured out the solution yet? That question, that willingness to challenge conventional wisdom, is Kaiser's enduring legacy. It is carved not in steel but in transformed understanding of what dedicated people can accomplish when freed from the constraints of tradition and challenged to attempt what experts claim cannot be done. From December 1940, when Kaiser signed his first shipbuilding contract knowing absolutely nothing about ships, to November 1942, when the Robert E. Peary launched after less than 5 days of construction, to September 1945, when the last Liberty ship was delivered, Kaiser proved something profound. Industrial revolutions do not happen through small, incremental improvements. They happen through fundamental reimagining of what is possible. The 2,710 Liberty ships built between 1941 and 1945 carried more than cargo across oceans. They carried proof. Proof that human ingenuity, when freed from tradition and driven by necessity, can accomplish things that seem impossible. Proof that ordinary people are capable of extraordinary achievement. Proof that the only real limits are the ones we accept without questioning. Kaiser walked into an industry that had operated essentially the same way for hundreds of years. He had no experience, no expertise, no reputation. What he had was a willingness to look at the problem fresh, without preconceptions. He asked why at every step. Why do we rivet instead of weld? Why do we build sequentially instead of in parallel? Why do we require years of training for tasks that could be taught in weeks? Why do we accept 8 months as normal when physics does not actually require it? Every time someone said, "That is just how it is done," Kaiser asked, "But why?" And when the answer was, "Because that is how we have always done it," he knew he had found an opportunity. The traditional shipbuilders were not stupid. They were not lazy. They were trapped by their own expertise. They knew so much about the right way to build ships that they could not imagine there might be a better way. Their knowledge became their prison. Kaiser's ignorance became his freedom. He could see possibilities they could not because he was not blinded by expertise. This is one of the paradoxes of innovation. Sometimes knowing too much about how things are currently done prevents you from seeing how they could be done differently. Sometimes the outsider has an advantage precisely because they do not know what is supposed to be impossible. But here is the important part. Kaiser was not just lucky. He was not just in the right place at the right time. He had a systematic approach to problem solving that made his success repeatable. First, he looked at the fundamental goal. Not how ships are built, but what is a ship supposed to do? It needs to float, carry cargo, survive ocean conditions. That is it. Everything else is negotiable. Second, he analyzed the current process to find inefficiencies. Sequential construction creates bottlenecks. Riveting is slow. Skilled labor is scarce. Third, he borrowed solutions from other industries. Assembly line production works for cars, why not ships? Welding works for pipelines, why not hulls? Fourth, he tested his ideas rapidly. Build one ship, see what works, improve the next one. Fifth, he empowered his workers to solve problems on the spot rather than waiting for permission from engineers. This systematic approach to innovation is more important than any specific technique Kaiser invented. The welding, the prefabrication, the parallel production, those were tactics. The real strategy was the mindset. Question everything. Borrow ideas from anywhere. Test rapidly. Learn from failures. Empower people closest to the work. That mindset can be applied to any industry, any problem, any challenge. And here is what makes the Liberty ship story especially powerful. Kaiser proved his approach not through arguments or theories but through undeniable results. He did not write papers about how shipbuilding could be improved. He built ships. Lots of them. Fast. Cheap. Good enough to win a war. You cannot argue with that. When the Robert E. Peary launched after 4.5 days, every traditional shipbuilder who said it was impossible had to confront the fact that they were wrong. The ship was right there, floating in the water, ready for service. Impossible had just become possible. This is why demonstration is so powerful. You can tell people something is possible, but they will doubt you. You can explain how it could be done, but they will find reasons it will not work. But when you actually do it, when you create physical proof that cannot be denied, resistance collapses. The Robert E. Peary was not just a ship. It was an argument that could not be refuted. It was proof that made further debate unnecessary. The workers who built that ship, who built all those ships, they learned something that changed them permanently. They learned that they were capable of far more than they had believed. A woman who thought she could only work as a secretary discovered she could weld steel and build ships. A man who thought his farming skills were not valuable in industry discovered he could learn complex manufacturing in weeks. A teenager who thought skilled trades required years of apprenticeship discovered she could become productive in days. These were not small lessons. These were life-changing realizations about human potential. And those realizations spread. The workers went home and told their families. They told their friends. They became living proof that ordinary people could do extraordinary things. When the war ended and they moved on to other jobs, they carried that confidence with them. They knew they could learn new skills quickly. They knew they could solve complex problems. They knew they were not limited by what they had done before. That psychological shift, multiplied across tens of thousands of people, helped fuel America's post-war economic boom. But the lesson extends beyond individual workers. Organizations learned too. Companies that adopted Kaiser's methods saw their productivity soar. Industries that had been stuck in traditional patterns for generations suddenly transformed. The idea spread that you could dramatically improve performance by rethinking fundamental processes. This became the foundation of modern operations management, industrial engineering, continuous improvement programs. The Liberty Ship program was a case study that proved systematic innovation works. Governments learned as well. The fact that American industrial capacity could be ramped up so quickly, so dramatically, changed strategic calculations worldwide. It proved that industrial potential matters as much as military might. It showed that underestimating your opponent's ability to mobilize resources and innovate is a fatal mistake. Japan made that mistake. They assumed American production was good but limited. They did not account for Kaiser and the Industrial Revolution he triggered. By the time they realized what was happening, it was too late. The ships were already being built faster than they could be sunk. There is also a lesson here about diversity and inclusion, though that is not a term people used in the 1940s. Kaiser's willingness to hire and train women, African Americans, and other people traditionally excluded from skilled industrial work was not primarily about social justice. It was about necessity. He needed workers, and he could not be picky. But the result proved something important. Talent and capability are distributed much more broadly than traditional hiring practices assumed. Women could weld just as well as men given the training. African Americans could operate complex machinery just as skillfully as whites given the opportunity. The only barrier was access, not ability. This had profound implications that extended far beyond the shipyards. Once people saw women doing skilled industrial work successfully, it became harder to argue that women belonged only in certain jobs. Once people saw integrated workforces producing at record levels, it became harder to justify segregation on grounds of efficiency. The Liberty Ship program did not solve America's problems with discrimination, but it did create cracks in the system. It provided proof that the old assumptions were wrong. And those cracks eventually widened into the civil rights movements and women's liberation movements of later decades. Kaiser himself was not perfect. He was a businessman driven by profit and success. He made decisions that prioritized production over worker safety at times. The rapid construction schedules created dangerous working conditions. Accidents happened. People were injured, and some died. The boom towns that grew around his shipyards faced serious problems with housing shortages, inadequate infrastructure, and social tensions. The environmental impact of rapid industrialization was ignored in the rush to produce. These are real issues that should not be glossed over. But they also do not negate the fundamental achievement. Kaiser proved that radical improvement in industrial productivity was possible through systematic innovation and organizational change. The question we should ask ourselves is, where are the Liberty ship opportunities today? What industries are stuck in traditional patterns that could be revolutionized by an outsider asking why? What impossible tasks could be accomplished by breaking them into simple components and training people quickly? What breakthroughs are waiting for someone who does not know enough to realize they should not try? These opportunities exist. They always exist. The question is whether we have the courage to pursue them. Consider healthcare. Medical training requires years of education and residency. But how much of a doctor's work could be broken into specific, trainable tasks? Could we create medical technicians who specialize in one procedure, learned in weeks rather than years, freeing doctors for more complex cases? That is a Kaiser-type question. Traditional medical education would say no, you need comprehensive training. But maybe that is just how we have always done it, not how it has to be done. Consider construction. Buildings are still built largely on-site, with skilled trades working sequentially. But what if we prefabricated entire rooms in factories and assembled buildings like Kaiser assembled ships? Some companies are exploring this. But the construction industry largely resists because that is not how we build buildings. That is a Kaiser-type opportunity. Consider education. We assume learning requires years of sequential instruction, everyone moving at the same pace through standardized curricula. But what if we broke knowledge into specific, masterable components and let people learn each one as quickly as they could? What if we focused on demonstrating competency rather than accumulating credit hours? That is a Kaiser-type question. Traditional educators would resist because that is not how education works. But maybe it could work differently. The point is not that these specific ideas are definitely right. The point is that every industry has assumptions that could be challenged. Every field has experts who know so much about the current system that they cannot imagine alternatives. Every impossible task might just be a problem that nobody has solved yet. The Liberty ship story teaches us to question those assumptions, to look for inefficiencies, to borrow solutions from other domains, to test ideas rapidly, to empower people to solve problems. Kaiser did not invent any new technology. Welding existed. Prefabrication existed. Assembly lines existed. Cranes existed. What Kaiser invented was a new combination of existing tools applied to a problem in a new way. That is often how breakthroughs happen. Not through inventing something completely new, but through recombining existing elements in novel configurations. The genius is in seeing the possibility of the combination, not in creating the individual components. This is hopeful because it means breakthroughs do not require waiting for some brilliant invention. They require creative recombination of what we already have. That is accessible to more people. You do not need to be a genius inventor. You need to be a creative systems thinker who can see possibilities others miss. Kaiser was that kind of thinker. And there is no reason more people cannot develop that skill. The Liberty Ship program also teaches us about the power of clear, urgent goals. Build ships faster than they can be sunk or lose the war. That clarity focused everything. Workers understood what was at stake. Managers understood the priority. Engineers understood the constraints. There was no ambiguity, no conflicting objectives, no confusion about what success looked like. That clarity enabled rapid decision-making and relentless focus. Modern organizations often lack that clarity. They pursue multiple objectives that conflict. They tolerate ambiguity about priorities. They spend time debating rather than doing. The Liberty Ship program shows the power of ruthless clarity about the goal. But clarity alone is not enough. Kaiser also created a culture of problem-solving at every level. Workers were not just told what to do. They were empowered to figure out how to do it better. If a welder found a faster way to join two pieces, they did it. They did not need to submit a proposal to management, wait for approval, pilot the new method, and then gradually roll it out. They just did it, and if it worked, others copied it. That kind of distributed innovation is incredibly powerful. The people closest to the work often have the best ideas for improving it. But most organizations do not tap that knowledge because they centralize decision-making and discourage deviation from standard procedures. Kaiser's approach was the opposite. He set the goal, provided the resources, and then trusted his workers to solve problems. This only worked because he also invested in training and created systems that made good performance possible. You cannot just tell untrained people to figure it out. You have to give them the tools, the knowledge, the systems, and then empower them within that structure. Kaiser did both. He created robust systems and empowered people to innovate within them. That combination is what made the extraordinary productivity possible. The speed at which the transformation happened is also instructive. From signing the first contract in December 1940 to launching the Robert E. Peary in November 1942 is less than 2 years. In that time, Kaiser built shipyards, trained tens of thousands of workers, developed new construction methods, refined those methods through iteration, and achieved production rates that shattered all previous records. 2 years. That should make us question how long we think major changes require. How often do organizations say, well, that kind of transformation would take a decade? Maybe it would, if you move slowly and cautiously. But maybe it would take 2 years if you moved with urgency and focus. The Liberty Ship program proves that radical transformation can happen much faster than conventional wisdom assumes. Of course, the wartime context provided advantages Kaiser would not have in peacetime. Government contracts guaranteed demand. Regulatory barriers were lowered. Resources were mobilized quickly. Workers were motivated by patriotism, not just pay. These factors helped, but they do not explain everything. Other shipbuilders had the same advantages and did not achieve the same results. Kaiser's specific approaches, his systematic innovation, his willingness to challenge assumptions, those were what made the difference. The context enabled the opportunity, but Kaiser's execution captured it. As we wrap up this story, I want to come back to the human element. Because ultimately, this is a story about people. About Henry Kaiser, a man who saw a problem and decided to solve it even though he had no business doing so. About Clay Bedford and Edgar Kaiser and the other leaders who executed the vision. About the engineers who translated ideas into reality. About the workers who learned new skills, worked brutal hours, and built ships at impossible speed. About the women who proved they could do skilled industrial work. About the African Americans who broke barriers in integrated workplaces. About the communities that grew around the shipyards and then adapted when the work ended. These were real people, living real lives, facing real challenges. They were not heroes from mythology. They were secretaries and farmers and housewives and laborers who found themselves in extraordinary circumstances and rose to meet them. That is what makes the story so powerful. If they could do it, why can't we? What extraordinary things are we capable of if given the training, the opportunity, the challenge? The 2,710 Liberty ships that slid into the water between 1941 and 1945 carried troops, carried tanks, carried food, carried fuel. They kept Britain from starving. They supplied the armies fighting across Europe and the Pacific. They made Allied victory possible. But they carried something else too. They carried proof. Proof that impossible is just a word. Proof that ordinary people can achieve extraordinary things. Proof that industries can be revolutionized. Proof that human potential exceeds what we assume. That proof still matters today. Every time someone says, "That is impossible," we can point to the Liberty ships and say, "People once thought you could not build a ship in days, and then Henry Kaiser did it." Every time someone says, "We have always done it this way," we can ask, "But is that the only way it can be done?" Every time someone says, "That would require too much change," we can remember that American shipbuilding transformed completely in less than 2 years. The Liberty ships give us permission to dream bigger, to challenge assumptions, to attempt the impossible. So here is what I want you to take from this story. First, expertise can be a trap. Sometimes the people who know the most about how things are currently done are the least able to imagine how they could be done differently. Do not let knowledge of current limits blind you to future possibilities. Second, complex tasks can often be broken into simple components. What seems impossible as a whole becomes achievable when divided into pieces. Third, training can be faster than we assume. You do not always need years of comprehensive education. Sometimes weeks of focused instruction on specific tasks is enough. Fourth, systems matter as much as skills. Kaiser's workers were productive not just because they learned skills but because the systems around them made productivity possible. Fifth, demonstration beats argumentation. Prove your idea works, and resistance collapses. Sixth, clear goals focus effort. Know what success looks like, and make sure everyone else knows too. Seventh, empower the people closest to the work. They often have the best ideas for improvement. Eighth, borrow ideas from everywhere. Solutions from one domain can transform another domain. Ninth, test rapidly and iterate. Do not wait for perfection. Try something, see what works, improve it. 10th, believe in human potential. People are capable of far more than conventional wisdom assumes. The Liberty ships were built by people who did not know they were supposed to fail. They tried anyway, and they succeeded beyond anyone's wildest expectations. That same spirit of possibility, that same willingness to question limits, that same belief in human potential, it is still available to us today. We just have to choose it. We have to decide that impossible means figure it out, not give up. We have to look at our own industries, our own challenges, our own limits, and ask why. Henry Kaiser has been gone for decades. The shipyards are quiet. Most of the workers have passed away. But the lesson endures. When someone tells you something cannot be done, ask them why. When they say, "That is how we have always done it," ask if there is a better way. When they say it would take too long or cost too much or require too much change, remember that American shipyards went from 8 months per ship to 4 days per ship in less than 2 years. Remember that farmers and secretaries became skilled shipbuilders in weeks. Remember that 2,710 impossible ships got built anyway. That is the power of questioning assumptions. That is the power of systematic innovation. That is the power of believing in human potential. That is the legacy of the Liberty ships. And it is a legacy we can claim for ourselves if we have the courage to try. If you enjoyed this story about how one man revolutionized an entire industry and proved that impossible is just another word for not yet solved, make sure to subscribe to the channel. Hit that like button. Leave a comment about what impossible challenges you think could be solved with a Liberty ship mindset. Because there are more stories like this out there. More moments when someone looked at conventional wisdom and said, "I bet we can do better." More times when ordinary people achieved extraordinary things. More proof that human ingenuity can overcome any obstacle. And I will keep bringing you those stories. But only if you subscribe, so I know you want to hear them. Thanks for watching, and remember, impossible just means nobody has figured it out yet.